Good morning. So today the class is about Weins law and the Planck's law and Raleigh-Jeans law. So in quantum theory of radiation, we completed the introduction part. That is what is a quantum theory and who given the quantum theory or who proposed the quantum theory, and black body and where is black body, and also we completed the energy spectrum due to the distribution of energy, okay, in a black body. So now coming to the main law, that Weins law. Okay, so Weins law explains that the energy distribution over the different wavelengths. Okay, Weins showed that as the maximum energy point shifted toward the shorter wavelength side when the temperature of the body is raised. Suppose let us consider a body when the temperature is raised for this body at higher temperatures. According to the Weins, what it shows means the maximum energy shift towards the shorter wavelength side rather than the longer wavelength side. So the Weins law is applicable to the shorter wavelengths. Okay, Weins law is applicable to the shorter wavelengths. So the given formula is lambda m T is equal to constant, where lambda m is a wavelength corresponding to the maximum energy from a black body at the absolute temperature T. Okay, so he also showed the maximum energy emitted by a black body is proportional to the fifth power of its absolute temperature. That is, E lambda of maximum is directly proportional to the T power 5. So it also known as fifth power law. So also known as Weins displacement or Weins law. So this is the equation for the equipartition of kinetic energy when we allow the principle of Weins law. E lambda is equal to C1 and C2 are the constants, arbitrary constants. Lambda power minus 5 into exponential of minus C by 2, C2 by lambda T. So this is a Weins distribution law if we apply the kinetic energy of partition. Okay. Then next theorem is one of the important theorem in unit 3 is Raleigh-Jeans law. Raleigh-Jeans law. So it is also developed. He developed the theory for the spectral distribution of black body radiation. Okay, spectral distribution of black body radiation by the application of the electrodynamics and statistical dynamics. So Raleigh-Jeans law uses the electrodynamics as the statistical mechanics for the explanation of distribution of the black body radiation. So he considered, for this experiment, they considered a halo cube. Okay, halo cube enclosed of side L. Okay, a cube of side L, right? Halo cube of side L with the side L with the perfectly reflected walls. With the perfectly reflected walls like this. Let us consider. Okay, so he considered a cube, halo cube of with the side L. Okay, with the side L and with the reflecting walls. So let us place a black particle inside the enclosure. If we place a black particle inside the enclosure, okay, if we are placing a particle, any particle, black particle inside the enclosure. Now the radiations emitted by the particle will be, it is in the cube and we are considering a particle inside, a black particle inside it. So as the radiation is going to be emitted by the particle, then it will be reflected by the walls. Okay, reflected with the walls. Then according to the electromagnetic theory, the radiation is supposed to consist of number of waves. So according to the magnetic theory, electromagnetic theory, what is the radiation? Radiation is a consists of waves, that is the stationary waves, which the waves travels in all the possible directions, that is X, Y, Z, and undergoes multiple reflections, okay, in the walls of the enclosure. Now the reflected waves interfaces with the corresponding incident wave to form a stationary waves. Similarly, these waves forms like a sound waves. So now we are considering an enclosure with the length L with all the possible directions X, Y and Z, okay, making an angle alpha, beta and gamma, okay, alpha, beta and gamma. Now let us make a formula or use a formula of the stationary waves when a bar is in both the ends, when a wire of length L is fixed at the both the ends and we pluck it, what happens? The formation of waves will be seen. So they can form the number of loops like n loops. Okay, the formation of the stationary waves, we have the formula n lambda by 2 is equal to L. We are plucking out at the midpoint. N is the number of waves, lambda by 2 is the half of the wavelength, is equal to the total length of the wire. Then from this, the lambda is equal to 2L by n, where n is equal to 1 to 3 into infinity. So we know that the velocity of light is equal to nu lambda, okay, mu lambda, and from this mu is equal to c by lambda. Always the frequency of the wave of a particle is inversely proportional to the wavelength of that given substance. Now we know that mu is equal to c by lambda, right? Mu is equal to, what is the lambda value? Okay, 2L by n, that is n by 2L, where n is equal to integral multiples. Right? So I said the particle will move in 3 different directions, all the possible directions. We have mu value c n by 2L, okay. Then nx is equal to, the waves traveling in x direction is equal to 2L by lambda, okay. Then, and from this L value, nx into lambda by 2. Similarly, the L value in all the directions will be ny lambda by 2 and nz lambda by 2 with all the possible axes alpha, beta and gamma, right? Then, what the values we got? L is equal to nx lambda by 2. Okay, nx lambda by 2. If we take an angle alpha, that is L cos alpha is equal to nx lambda by 2. Okay, L cos alpha is equal to nx lambda by 2. L cos beta is equal to ny lambda by 2. And L cos gamma is equal to nz lambda by 2. So the cosine's law is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Right? Now all the squares of the angles is equal to 1. Cosine angles will be 1. So from the equation 3 and 4 we can write that nx square plus ny square plus nz square is equal to 2L by lambda whole square. Okay, as nx square plus ny square and nz square is equal to r square, then r square is equal to 2L by lambda whole square, where r is equal to 2L by lambda. So we got the r value. Okay, so nx and ny and nz are the direction of the coordinate axis. Okay, now similarly let us consider a circle. Okay, or before going to form a circle, if we form in a two-dimensional plane, okay, if we see in this experiment in a two-dimensional plane, what will be the direction? The directions will be only two, that is x and y. So then nx square plus ny square is equal to 2L by lambda whole square. Now let us represent a circle. So this equation represents a circle, like x square plus y square is equal to a square. So this represents a circle. So we are plotting nx, okay, on x-axis and ny directions on the y-axis. Like this we plot a graph. So every point of intersection makes a mode of vibration. Every point shows the mode of vibrations. Now we consider only the positive values of the vibrations, that is nx, where nx and ny will be positive. Now the area of the each square, okay, the area of the each square is unity. So hence the number of square, how we will calculate? The area of the quadrant, that is 1 by 4 pi into radius. Radius is nothing but r square. Now totally the formula is 1 by 4 pi into 2L by lambda whole square. Then 2 and 2 gets cancelled. Pi L square by 2 lambda. Okay. Sorry, 4 and 4 gets cancelled. Then the remaining term is lambda L square by pi L square by lambda square. Now, if the wavelength, let us consider the wavelength lies between the lambda and lambda plus d lambda. Then the frequency modes of vibration, okay, frequency modes of vibration will be 1 by 8. Okay, if we take the circle in 3-dimensional space, how it look like? It look like spheres. So, what is the volume of the sphere? 4 by 3 pi r cube. So, then the frequency will be F is equal to 1 by 8 into 4 by 3 pi r cube. That is 1 by 8, 4 by 3 pi into, what is r value? 2L by lambda. That is 2L by lambda whole cube. So, and differentiate this equation, what will get? For the f differential, we get df is equal to, we are differentiating with respect to lambda. That is 4 pi L by 3 will be remaining same. Then 1 by lambda cube is nothing but d by d lambda of 1 by cube. Then what will get? Minus 3 by lambda 4 into d lambda. So finally df is equal to 4 pi v by lambda power 4 into d lambda, where v is the volume of the enclosure. Right? Now what we are doing? We are multiplying the above number with the 2, as the transverse electromagnetic wave have 2 polarizations for the each mode. For the each mode, we will get 2 polarizations waves. So, for the 2 polarization electromagnetic waves, we multiply this equation into 2. Okay, then df is equal to 8 pi v by lambda power 4 into d lambda. When the volume extends to unity, that is the v is equal to 1, volume is equal to 1, then the number of modes of vibration per unit volume is 8 pi d lambda by lambda bar 4. So, we have the formula for the energy density. Okay, energy density E lambda d lambda is equal to total number of modes into average energy per mode. Okay, then what we have? Energy. Okay, na? Energy density E lambda d lambda is equal to the frequency into average energy, that is equal to kT. Means K is the Boltzmann constant and T is the absolute temperature. Then E lambda d lambda is equal to, okay, E lambda d lambda is equal to 8 pi kT by lambda power 4 into d lambda. Okay, this is the Raleigh-Jeans formula for the energy distribution. Kindly follow the classes regularly.